Welcome back to part 3 of the unit circle. All right, so first video we introduced what the unit circle was, how we found all the pieces using that right triangle trig, so on and so on. In part 2 we broke down our 45-degree reference angles, okay, and what I want to do here is continue all that great work we did. Notice we filled out a good chunk now. Filled out a really good chunk now of the unit circle. Now I want to continue that work. Okay, so I'm going to go ahead and get us some new space. All right. And let me go ahead and draw a new circle. Okay, and now what I want to focus on is our 30-degree reference angles. So let's say I rotated an angle, and let's say this was 30 degrees, okay? And let's actually draw all of our 30-degree reference angles. So if I did another one, let's say I created a right triangle over here where this angle was 30. What would this whole angle be? If this little angle in here was 30 degrees, what would this full angle here be? Well, it would be. Hopefully you're able to get that. That would end up being 150 degrees. Hold on, let me switch colors real quick. That full angle there would be 150 degrees. So let's go ahead and kind of keep going. So there would be our other one. Let's say we had another one right here. This is another 30-degree measure. Now what would this full angle be? What would that full angle be? That'd be 210 degrees, right? Because we went a full 180, then another 30. And let's say we went, again. Let's say this angle here was 30 degrees. What would that full angle be? Think about it. What would this full angle be? 330 degrees. All right, so we have all of these angles. So all 4 of these angles have the exact same reference angle of 30 degrees. Okay, let me clear this up a little bit so we don't get too confused on anything, but all of those angles would end up having 30-degree reference angles. Okay, now let's go ahead and take a look at just our first one. Okay, now this point here, what would this point be? Well, let's break it down. All right, this is 30 degrees, and remember to find the x-coordinate, we use cosine of the reference angle, and to find the y-coordinate, we use sine of the reference angle. Okay, so x is cosine of the reference angle, and the reference angle is 30 degrees, and hopefully you remember those special angles. Remember in our special right triangles video, I told you we should definitely try to memorize sine and cosine of 30, 45, 60 degrees. Hopefully you remember cosine of 30 degrees is the square root of 3 over 2. So the x-coordinate here will be the square root of 3 over 2. And the y-coordinate, remember, is found by doing sine of the reference angle. And hopefully you remember what sine of 30 degrees is. It's 1/2. All right. So there is our 30-degree measurement. Let's go ahead and fill that in. All right, let's go ahead and fill that in. So 30 degrees, which is pi over 6 radians. Try to get these conversions while I'm going. Would have an x-coordinate of root 3 over 2 and a y-coordinate of 1/2. Okay, so let's go ahead and continue. All right. So remember our next one is 150 degrees, which would end up being 5 pi over 6 radians. Now I'll fill out what that is in a second. I just want to quickly kind of go back over how we get that. Okay, so remember for 150 degrees, we still have a reference angle of 30 degrees, okay? We still have a reference angle of 30 degrees, and remember, the hypotenuse of all these triangles is 1 because the unit circle has a radius of 1. Okay, so for over here, if I'm trying to find this coordinate right here, I'm still using this right triangle. I'm still using cosine of 30 and sine of 30. Okay, because it has the exact same reference angle. So I end up using the exact same values. Okay, so x is still going to be root 3 over 2, y is still going to be 1/2, kinda, but remember, we're in quadrant 2 now, and x in quadrant 2 is negative. So that means that x is negative root 3 over 2, and y is a positive 1/2 at 150 degrees. Now remember, this full angle here is 150 degrees, okay? Because the full rotation, the full half rotation here would be 180 degrees, but I'm going 30 degrees back. That means I'm at 150, okay? Now, I can do another one, right? I can do another one. And this angle here is once again 30 degrees. This angle here is once again 30 degrees. So I would end up with the exact same values, except I'm in quadrant 3, where x is negative, but y is also negative. And remember, this full rotation, although I'm using a reference angle here, these are the coordinates for a full rotation of 210 degrees. That's because we went 180 and an extra 30 to get to this value right here, to get to this point. All right, and then another 30-degree reference angle. Notice these aren't drawn to scale, guys. If you really want to, you can draw this to scale, but I'm lazy. All right, so another 30-degree value right here. So once again, x is going to be cosine and y is going to be sine. So once again, I'm going to get the square root of 3 over 2 for x. And since we're in quadrant 4 here, x is positive, but because we're in quadrant 4, y is negative. So x is positive in quadrant 4, y is negative. So notice that all of these have roughly the same coordinates because they have the exact same reference angle. Okay, and that full rotation, think about what it would be. Well, one full rotation all the way around is 360 degrees, but we went 30 degrees back, which is why that's 330 degrees. So now we can go ahead and fill that in. This was 210 degrees. Notice 30 more than 180, which is 7 pi over 6 radians. X and y are both negative in quadrant 3. And in quadrant 4, that's 330 degrees, which is 11 pi over 6 radians. X is positive in quadrant 4, and y is negative in quadrant 4. So notice all the 30-degree reference angles. Notice 30 degrees below 360, a full rotation. Remember, reference angles always with the x-axis. Notice that all the 30-degree reference angles, 30, 150, 210, 330, they all have a reference angle of 30. Notice they all have very similar coordinates. I forgot to draw this one over here. X would be negative root 3 over 2. Y would be positive 1/2. Notice they have roughly the same coordinates, okay? Very, very similar. And also notice that the radian measures all kind of end with pi over 6. 1 pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. A similar relationship that the 45-degree reference angles had. Remember, we had pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Those were all the 45-degree reference angles. Well, notice 30-degree reference have a similar pattern. They end with pi over 6. Okay, we're almost there. All we got is our 60-degree measures. If you want to try that out on your own, feel free, but I will be taking a look at those in our next video. All right, and until then, goodbye.